Real numbers. Second part. Okay, let us move on to our exercise section. And our first problem is express each number as a product of its prime factors. Okay, this is our first question. We have 5 numbers here. We have to express it as a product of prime factors, which is an easy question. Then what is a 140? 140 is what? 140 is 70 into 2. What is 70? 35 into 2. Then what is 35? 7 into 5. Then what is 140? 140 equal to 2 into 2 into 7 into 5. That is 35 into 2, 70 into 2, 140. Therefore, we can rearrange the term as 140 equal to 2 square into 7 into 5. This is our answer. Then, next 156. What is 156? Which is 2 into 78. Or either you can proceed it by checking whether it is divisible by the prime factors. So here 156 is here, that is, okay, first we can write its prime factorization, then we can move on then like that. That is 2 into 78. 2 into 78, that is 78 is 39 into 2. That is 39 is 3 into 13. Or otherwise you can move like this. 2 is divisible on 156. That is why here we have an even number as in the last digit. Okay. So it is divisible by 2. Then on dividing by 2 we will get 78. What about 78? Again it is divisible by 2. Then we will get 39. 39 equal to 3 into 30. That is 39 is divisible on 3. Why 39 is divisible on 3? 3 plus 9 is 12. When we get a by adding the numbers, if we get something as a multiple of 3, then it is divisible by 3. That is 39 equal to 3 into 30. So 156 equal to 2 square into 3 into 30. Then 3825. It is divisible on 5 correctly since it ends with 5. Okay. Then what is the quotient on dividing by 5? That is 5 into 3, 5 into 7, 35. 32 will remain here. 5 into 6, 30. 25, that is 765. 765 is again divisible on 5. On dividing by 5, we will get 5 into 1, 5. 2 will remain. 5 into 5, 25. Again 15. That is 5 into 3, 15. So 5 into 5 into 153. Then 153. On considering 153, it is not divisible by 2. Since it is ending digit is not an even. Then what about 3? Yeah, it is divisible by 3 by 1 plus 5, 6, 6 plus 3, 9. So it is a multiple of 3, so it is divisible by 3. On dividing by 3, we will get 51 here. 51 is again divisible by 3, that is 51 by 3 is 70. It is 5 into 5 into 3 into 3 into 70. Okay, 5 square into 3 square into 70. It is its prime factorization. Now, next problem, let us do it by the factorization method. So, we can apply different methods here to find the problem, answer of this problem. Okay. So, I am introducing all the methods here. So, what is 505? It is 5005. It is divisible by 5 clearly. Okay. So, 5005 equal to 5 into 1001. Then now we can do the prime factorization here. That is, we have 5005, and what is the quotient? 1001. So consider 1001 here. Is it divisible by 2? No. Since it is not an even number, it is not divisible by 2. Then about 3, by adding in terms we will get 2. That is not a multiple of 3. So 1001 is not divisible by 3. Then what about 5? There is no possibility. Then about, in order to divisible by 5, we have to get the last digit at 0 or 5. Okay. Then what about 7? 7 into 7 ones are 7, then 30, 7 to 4, 28, 2, 21. Okay, it is divisible by 7. That is, on dividing by 7, we will get 143. Then what about 143? Not divisible by 2, 3, since 4 plus 3, 7 plus 1, 8. Then what about 5? No, 7. 7 into 2, 14. 3 is our remainder. Then what about next prime number? That is 11. Yeah, it is divisible by 11. Then what is it? Quotient on dividing by 11? 30. Yeah. So the prime factorization of 5005 equal to 5 into 7 into 11 into 30. Here next problem, I am giving you something extra. Okay. That many of you may not know that. There is some divisibility checks for 7, 9, 11, etc. Okay. Let us study that too if you are interested, or you can do it by prime factorization method and find out what is each prime factorization. Then what is 7 for 9? Okay, it is not divisible by 2. We have 17. I will explain you how we will get 17 here. It is not divisible by 2 since last digit is not an even number. Then what about 3? 7 plus 4, 11, 11 plus 2, 13, 13 plus 9, 22. Okay, also not possible. 22 is not a multiple of 3. Then what about 5? Last digit doesn't end with 5. Then what about 7? So we are checking a divisibility check text for 7. How to know a number is divisible by 7 or not? That is, for that we have to multiply 2 to the last digit. That is 9 into 2, 18. And we have to subtract 18 from 742 here. If it is a factor of 7, then this number is divisible by 7. It is the divisibility check for the 7. So, we know that 1001 is divisible by 7. So, let us check that. That is, last digit is 1. Multiplying 1 by 2, we will get 2. 100 minus 2 is 98. Okay, 98 is divisible by 7. So, how to check 98 is divisible by 7? That is 8 into 2, 16. 9 minus 16 is minus 7. So, minus 7 is divisible by 7. So, we have to ignore here the signs here. That is 7 minus without caring much about minus 7. It is divisible by 7. That is without the sign, you can say it is divisible by 7. Okay, let us have the check here. So, we have to ignore the sign here. It is 742 equal to, 742, 9 into 2, 18. By minus subtracting it from 742, we will get 724. What about 724 whole to 8? 72 minus 8 will give 62. 62 is not clearly divisible by 7. So, 7429 is not divisible by 7. Then, what about next? Next, we have the divisibility check for 11. What is the divisibility check for 11? Here also we have to ignore the sign that is positive or negative and to check whether the value is divisible by 11 or not. Okay. Then, what is the divisibility check for 11 is that alternatively we are putting minus plus here. That is 7 minus 4 plus 2 minus 9. Okay. Or 7 plus 4 minus 2 plus 9. And to find whether that number is divisible by 11 or not. So, then we know that 143 is divisible by 11. Then let us check this. That is 1 minus 4 is minus 3. Minus 3 plus 3 is 0. So 0 is divisible by 11. So 143 is divisible by 11. So let us have the check here. It is quite easy. That is alternatively you have to put plus minus plus minus. Okay. 7 plus 4 minus alternatively plus, that is 7 plus 4 minus 2 plus 9, which is 18, which is not divisible. So, given number is not divisible by 11. Then next we are moving to divisibility check for 30. What is it? That is, in order to get divisible by 30, we have to multiply the given number by 9. Okay, last digit by 9. That is 9 into 9, 81, and we have to subtract it from 742 and to check whether that number is divisible by 13 or not. Here 143 is divisible by 30. So let us have that check. 3 into 9, 27. 14 minus 27 is minus 30. So we have to ignore the sign 30. 13 is divisible by 30. It is the procedure here. So on checking this number, 7429 minus 9 into 9 is 661. Then again taking multiple of 9 here. 66 minus 9 is 57, which is not divisible by 30. So the given number is not divisible by 30. Now let us move on to divisibility check for 70. Okay, what is it? It is, here we have to multiply the last digit by 5. Okay. Then after that we have to check whether it is, that is 5, and we have to minus it from, that is 9 into 5, and we have to minus it from 742 and to check whether it is divisible by 17 or not. Here 153 is the multiple, divisible by 17, that is 3 into 5, 15, 15 minus 15, 0. So it is not, it is divisible by 17. Similarly, by checking here, we will get 17 divisibility test, that is 742 minus 9 into 5, that is 45, it is 697. Again to check, 697 is divisible. 69 plus 7 into 5, 35, that is 34. Oh, 34 is divisible by 70. So here we got 7429 is divisible by 70. Then what will we get as our quotient for 37? Next, since this number is not divisible by primes up to 70, the 437 is not divisible by the primes up to 70. Let us check on next number. For the next check, what we have to do, that is 90, we have to multiply last digit into 2 and we have to add with 43. That is the divisibility check for 90. Okay. That is 742 plus 90. 9 into 8, 2, 18, that is 760. 760 is divisible by 90. How to know 760? That is 76. In order to continue this, we have to multiply this number into 2, that is 0 into 2, 2, plus 76. 76 is divisible by 19, that is 19 into 4 will give 76. Okay. So this number is divisible by 90. So in order to check another number, let us take 190. 190 means 0 into 2, 0, 0 plus 90, 90. So 190 is divisible by 90. Now by dividing 437 by 90, we will get 23 here. So what is the divisibility test for 23? If you are interested, please comment it. So here we are moving on to our next exercise. Express each number as a product of its prime factors. Find LCM and HCF of the following pairs of integers and verify that LCM into HCF equal to product of two numbers. So we have 3 steps. At first to find prime factors. Next step is to find their HCF and LCM. Third step is to verify this equation. Okay. Then for that, let's have the numbers at first. Okay. We have 3 questions here. Then our first question, it is, what is 26? It is 13 into 2. Okay. It is the prime factorization. Then what is 91? 13 into 7. Okay. So why we are putting 7 raised to 0 here? because 7's term is absent here, so we are putting 7 raised to 0. 2's term is absent here, so we are putting 2 raised to 0 here. If you want to avoid this, you can avoid that. Then what is the HCF among this? Least power of the common prime factors. Okay, which is the least here? Here 2, here 7, 2 raised to 0, here 13. 13 is having the power 1 in both cases, so we can take 13 here. Then 7 raised to 0. Then what is our HCF? 13 into 2 raised to 0 into 7 raised to 0. What about LCM? Here we have 2 as the highest power, having highest power 13. Since both powers are equal, and 7. Then what is our LCM? 2 into 7 into 13, and which is equal to 182. That is 91 into 2, 182. Then what about HCF? That is, we have to take least among that. That is 2 raised to 0 into 7 raised to 0 into 13. Then 2 raised to 0 and 7 raised to 0 is 1. So we are taking here 13. Then next we have to verify the relation. Okay, that is what is 13 into 182. Whether it is equal to 26 into 91. Okay. Let us check. 26 into 91 equal to 2366, and which is equal to 182 into 13, which is equal to HCF into LCM. You can verify this calculation. Okay. Then what is next? We have to find the prime factorization and HCF, LCM, and verify the relation among second question. Okay. That is 5 and 10. What is 5 and 10? 51 into 10. 51 is what is 17 into 3 is 51. 10 is 2 into 5. Okay. Then what about our 92? What is 92? 46 into 2. That is 46 is 23 into 2. That is 2 square into 23 is our 92. Then here we are not writing like this, and we can do this very directly. Then which is the smallest among this? 2. Okay. Then here we have no 3s, here we have no 5s, here we have no 17, here we have no 23. So in order to compare the common prime factors, only 2 is the common, and least among that will be our HCF. That is HCF equal to 2. Then what about LCM? It is the highest among common factors. Okay. Factors. Okay. Prime factors. Then what is this? LCM equal to 2 square into. Then here we have no 3. Here 3 raised to 1. So we are choosing 3 raised to 1 since it is the highest of the power into 5 into 17 into 23. So LCM is a greater number. That is 2 square into 3 into 5 into 17 into 23, which is 23460. So why we are taking like this? LCM is highest power of the given prime factors. Okay. Here 2 square is the highest. Here 3's term is absent here, but here 1 3 is present. So we are taking 3 raised to 1. Here 5, here 17, and here 23. Okay. So assume that here something is there, that is 3 raised to 0, 5 raised to 0, 17 raised to 0, here 23 raised to 0. Or you can write that. Then by verifying our relation, what we will get? 22 into 23460 equal to 46920, which is equal to 510 into 92. That is, hence we have verified our relation. You can do this by calculating by your own. Okay, and to verify whether this is true or not. Then, next, what is that? 336 and 54. What is 336? 3 into 1112. 1112 is what? 3 into 2 into 7 into 2 into 2. What is 112? 112 is what? That is 16 into 7, okay. Then, what about next term? That is 54. 54 is simple, that is 9 into 6, that is 2 into 2 into 3 into 3 into 3. So we have to rearrange them. So we are rearranging it as 336 equal to 2 raised to 4 into 3 into 7 and 54 equal to 3 cube into 2. Now we are putting 7 raised to 0 here. If you want, you can ignore this step. Then what will be our HCF here? Least among that is least among the power. 2 is the least here, 3 is the least here, 7 raised to 0 is the least by comparing the prime factors. Then what is our HCF? 2 into 3 into 7 raised to 0. 7 raised to 0 is 1, therefore 2 into 3 equal to 6. Then what will be our LCM? 2 raised to 4 into 3 cube into 7. It is 3024. Now we are going to verify this relation, that is 54 into 336 equal to 18144, which is equal to HCF into LCM. Okay. You can do for the calculation for further clarification you need. So moving on to next. Find LCM and HCF of the following integers by applying prime factorization method. Okay, so we have to apply prime factorization method in order to find the HCF and LCM of given numbers. Okay, so we have 3 questions here. We have to find the HCF and LCM. So for that, at first take these 3 numbers. Then, what is our prime factorization of 12? 12 equal to 3 into 2 square, that is 3 into 4, 3 into 2 square, 15, 3 into 5, 21, 3 into 7. Then what is our LCM and HCF? In order to find LCM, if you want, you can write here 5 raised to 0, 7 raised to 0, etc. Or either you can do by this method too. So, in order to find LCM, what we have to find? We have to find highest power among the given prime factors. Okay. Here 3 is common in both terms. So 3 is highest. 3 raised to 1 is highest power. So we choose 3 raised to 1 for LCM. Then here 2 square we will choose. Here 5 we will choose. 7 we will choose. Therefore LCM equal to 3 into 4 into 5 into 7. That is 3 into 2 square into 5 into 7. Which is equal to 420. Then what about HCF? Common prime factors. Sorry, the least power of common prime factor. Here common prime factor is 3 only and its least power is 1. Sorry, 3. That is 3 raised to 1 which is equal to 3. Therefore HCF equal to 3. Then what about next numbers? 17, 23, 29 are all prime numbers. So it is not a composite number, so we cannot decompose it into prime factors. So as it is, that is, they are prime numbers, so their prime factorization is 17, 23, 29, etc. Sorry, XL. So what is our HCF? Here, HCF equal to 1. Why? There are no common factors among these 3 numbers. Then what about LCM? We have to multiply 3 numbers in order to find LCM. Okay, since the greatest prime numbers, prime factors is that numbers itself. Greatest power of prime factors is that numbers itself. So, LCM equal to 17 into 23 into 29. That is 11339. It is in the same way, if we have 2 numbers 2 and 3, how we will find it our LCM 2 into 3. In the same way, we are finding this numbers LCM. The next 8, 9 and 25. Then 8 equal to 2 cube into 3 raised to 0 into 5 raised to 0. 9 equal to 3. 9 equal to 3 square into 2 raised to 0 into 5 raised to 0. Then 25 equal to 5 square into 3 raised to 0 into 2 raised to 0. Either you can write this like this, or you can apply this method. Okay, both are fine. Whichever is easy, you can adopt that. Then what is our HCF? We have to find common prime factors and to find least power among them. Here, 2 raised to 0 is least among 2s, 3 raised to 0 is least among 3s, 5 raised to 0 is least among 5s. So we can choose here 3 raised to 0 into 5 raised to 0 into 2 raised to 0, which is equal to 1. What it implies? There are no common factors among these three numbers. Okay, then what about LCM? We have to choose highest among these powers, that is 2 cube into 3 square into 5 square, which is 1800. This is our result, that is we got our number as 1800. So moving on to next, check whether 6 raised to n ends with digit 0 for any natural number n. So what we have to do, 6 raised to n ends with a digit 0 for some n. That is, if we put some value of n, we get the last digit of 6 raised to n equal to 0. What is 6 raised to n? If you put 1, we will get 6. 2, we will get 6 square, 36. Like that, we have to prove for some n, the last digit of 6 raised to n ends with the digit 0. Okay, let us check whether we can represent, whether we can find such an n or not. So for that, to prove the last digit of 6 raised to n is 0 for some n, what we are going to do is we are going to decompose 6 raised to n as a product of primes. Since 6 raised to n is a composite number, we can decompose it into a product of primes by the fundamental theorem of arithmetic. Since 6 raised to n is a composite number, we can express it into a product of primes by the fundamental theorem of arithmetic. Then what is 6 raised to n here? 2 into, since 6 is a composite number, 6 raised to n will be also a composite number. What is 6 raised to n? 2 into 3 whole raised to n. Okay, which can be written as 2 raised to n into 3 raised to n. Then again, how many 2's are here and how many 3's are here? That is n 2's are here. Product of n 2's are here and product of n 3's are here. Why is 2 cube is a product of 3 2's. 3 square is a product of 2 3's. Okay, like that here we have n 2's and product of n 3's. So again, decomposing, we will get 2 into 2 into 2, n times, 3 into 3 into 3, etc. n times. Okay, these are the prime factorization of 6 raised to n. Can we get an n such that the 6 raised to n ends with digit 0? Here I think it is not possible. Why? In order to end with digit 0, we have to get a multiple of 10 here. Okay, only the multiples of 10 ends with the digit 0. Or we have a factor like 10 here in order to get it to end with digit 0. That is 10, 20, 30, 50, 100. Every number ends with a digit 0 is a multiple of 10. So, why here we have no factor as 10? Because the prime factorization of 10 is 2 into 5. Here we have only 2. So, that is not possible to get the 10's multiple as 6 raised to n. Okay. So, the prime factorization of 6 raised to n have only 2's and 3's. So the last digit cannot be 0 for any n. For 6 raised to n, because to get 0 as a last term, we need at least one 5 as its prime factor. Because why? The prime factorization of 10 is 2 into 5. So we have if we have some 5, then this number will ends with digit 0. So we have no 5s here, only 2. So 6 raised to n never ends with digit 0. So moving on to next question. Given that HCF of 306 and 657 equal to 9, find LCM of 306 and 657. Which is a very easy problem by using our equality, that is AB equal to HCF of AB into LCM of AB. By using that result, we can proceed this problem easily. So we have LCM of AB into HCF of AB equal to AB. By applying this result here, LCM of AB equal to LCM of 306 and 657 equal to what we will get? Just here AB by HCF, that is 9. So that is 306 into 657 divided by HCF, that is 9. And what will be its value? LCM equal to 2, 2, 3, 3, 8. Okay, 2, 2, 3, 3, 8. Okay, let us move on to our next question. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So we have to explain why these two numbers are composite. Okay. For that, let us take the numbers. Okay. Here the 13 is common in both the two terms. Okay. Here 13 is a common term. Here 13 is a common term. We are taking 13 outside. Then what will remain? 7 into 11 plus 1. Then what is that? 13 into 78. Okay. Then we can decompose 78 into 13 into 3 into 13 into 2. That is, what is 78? 26 into 3. Then these numbers are prime numbers, so that we can express the number as the product of primes. Okay. Then what we can say? That is, which is equal to 2 into 3 into 13 square. And then what we can say? Hence 7 into 11 into 13 plus 13 are product of primes. Hence, by fundamental theorem of arithmetic, we can conclude that they are composite number. Okay, that number is a composite number. Then, similarly, we can proceed the next problem. Here, what is common term? 5 is the common term. Okay, here we have 5, here also we have 5. We are taking 5 outside, then what we will get? 7 into 6 into 4 into 3 into 2 into 1. That is, instead of 5, we have these terms. Then, here 5, if we take 5 outside, 1 will remain. Then, by multiplying and adding, we will get 5 into 1008 plus 1. Then, what is 5 into 1008 plus 1? 5 into 1009. Here, 5 is a prime number, 1009 is a prime number. So, what we can conclude? This number also can be represented as product of primes. Hence, by the fundamental theorem of arithmetic, we can conclude our result. Okay. Hence, by the fundamental theorem of arithmetic, the given number is a composite number. So, our next problem. There is a circular path around the sports field. Sonia takes 80 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So this is our question. What does the question mean? That is, there is a circular path. Let it be this thing. Okay. Around a sports field, Sonia takes 18 minutes to drive one round of the field. That is, Sonia takes 18 minutes to complete one drive, and the time taken by Ravi is 12 minutes. If they start from the same path, from the same point, let that be point this thing, and at the same time and go at the same direction they are moving, after how many minutes they will meet again at the starting point. That is, if they start from here and when they will meet at the starting point. That is, after how many minutes they will reach at the starting point. This is our question. Okay, let us look that in detail. That is what we have to do. That is, let this sun represent the Ravi and the star represent Sonia. Okay, that is, sun will take 18 minutes to complete their drive and the star will take 12 minutes to complete the drive. Then let us look what happens if they start together. Okay, that is the sun will reach at the starting point. That means Ravi will reach at the starting point faster than what? The star. Okay. Since they will take only 12 minutes, he will reach at the starting point at first. Then only who will reach? The star will reach. Okay. That is, okay. Then what we have to check when they will meet at the starting point. Okay, after they start. So for that, hence Ravi and Sonia is rounding around the same circular field but in a different speed. Okay, why they are in a different speed? Because one take 18 minutes and another take 12 minutes. Given Sonia take 18 minutes for one round and Ravi takes 12 minutes. Okay, they start together. We want to know when they will meet again at the starting point. So what we have to know? When they will meet at their starting point. Okay. So how we can find this? That is, when they will meet at the starting point. That is, we have to find, that is the common multiple among these two. Why we have to find common multiple among these two? That is, LCM. Why we have to find LCM? At first we can say one reason is that we have to find something more than this 18 or 12 minutes. Okay. So we have to find LCM. If there is lesser than 8 and 12, we will find our HCF. So why we are finding our LCM means we have to find what is the common multiple of two numbers. At that time, they will meet each other. That is, they will meet each other at the common multiple. Okay. That is, if you find a common multiple of them, and we have to find the least. Why we have to find the least? We have to find the minutes they will meet again. Okay. At the first meeting point, we have to find. So that for that we have to find the least common multiple among them. That is, the common multiple means that time is common to both. That is, something common to both. On that time they will meet each other. Okay, how to find this LCM? That is 18 equal to, by prime factorization method, 3 square into 2, then 9 into 2. Then what about 12? 3 into 2 square. Okay, then what is its LCM? LCM is highest power of common prime factors. Okay, highest power among the prime factors. Here 3 square is the highest, 2 square is the highest. Okay, then LCM equal to 36. So after 36 minutes, they will meet each other. Okay, let us have a look how it is happening. So here the Devi and who is that? Sonia is starting together. Okay, then see what will happen. At 12 minutes, okay, that is that after 36 minutes they will meet at the starting point. Okay, Devi here takes 12 minutes. What will we can check what will happen at the 12 minutes? That is 12 minutes, Devi will complete his full round. Okay, then what about Sonia? She will take 80 minutes for a drive. So after 12 minutes, she will be at this position. Okay. Then again, we can see what will happen after 24 minutes. That is after 12 minutes. Again after 24 minutes, Devi will complete one more drive. Then what about Sonia? She complete one round and she will be at here. Okay, then what will be the position at the third time? That is after 36 minutes, Devi will complete his drive, and what about Sonia? She will also complete his drive. That is, we have to find the least common multiple among that. On that time, both Devi and Sonia complete their drive.